Let's solve another problem with a sliding window. The problem is minimize size survey sum. So we are given some positive integer numbers and a positive integer target. We have to return the minimal length of a survey whose sum is greater than or equal to the target. If there are no such survey, we return 0 instead. So if my input is this and my target is this, the sub array which contains the sum which is equal to greater than or equal to 7 is 4 and 3. So this sub array contains the sum which equals to 7. So so that we just return the length of that sub array, and the length of this sub array is 2. So our output is 2. And if we consider this input, my nums is 1, 4, 4, and the target is 4. So if I have to calculate the sum, if I have to calculate the sum from a sub array whose sum is 4, that will be 4 itself, right? If I see, if I take this sub array and calculate the sum, it will be 5, right? And if I take this sub array and calculate the sum, will be 8. And if I take the whole, that will again be greater than the target, right? So what I can do is I can consider this as the subarray whose sum equal to 4, right? All right. So for this problem, I'm again going to use the sliding window approach. I guess now you are well aware of what a sliding window is and how we can use this pattern to solve the problems with the survey. Again, again, I have told you that there are some problems where we deal with surveys or sublist. We can solve this problem using sliding window. So this is a survey problem. So you already got the hint, right? Now you can use the sliding window here. See the see the idea is pretty simple. What I can do here is I will take a window over this array. Over this array, I will take a window, and what I will do is I will just keep expanding and shrinking the window. See, the idea is pretty simple. We take a window over this input and keep expanding it to include more elements. I will start from I will start my window from here, then I will keep adding the elements coming in, and I will stop once my subarray size has become greater than 7. So I have, let's say I have added 2 in my window. So the current window contains 2, and then I will again add 3. If I get the sum will be 5. Then I will add this one again, the sum will be 6. And then when I'm going to add this one, so 3 plus 2 is 5, 5 plus 1 6, and 6 plus 2 is going to 8. So here my window has become invalid, right? So so the my window will only be valid if it contains the element, if that subarray contains the element that has a sum greater than or equal to the target. And see what I need to return is I will not return this here. I will again check for a sub array who contain less elements. See what the problem is saying. See what the problem is saying. It's saying is whose sum is greater than or equal to the target. Okay, whose sum is greater than or equal to the target, and I have to return the minimal length of that sub array. So for this sub array, if I take the length of it, it will be 1, 2, 3, 4. Okay, so the length is 4. And if I take this subarray, the sum is 7, but the subarray length is 2. So what I will do is I will I will not return this. I will return the length of this subarray. Okay. Now see, eh, I will keep adding the elements into the window. Now, as soon as the sum of the window becomes greater than or equal to the target value, which is for this input is 7, we don't we don't just stop there, right? We don't stop there. Instead, we try to shrink the window from the left side to see we can find a similar subarray that still satisfy the condition. What is the condition? My condition is my the subarray elements, the subarray that contains the element is sum greater than or equal to target, and also its length is minimal length. So for this, the sum is greater than or equal to 7, right? The sum is 8. For this subarray, the sum is 8, which satisfies the condition, but it does not satisfy this condition. I have to return the minimum length of a subarray. So this is not, if I take this and if I take this, the minimal length will be this one, and its sum is greater than or equal to 7, greater than equal to 7. So what I will do here, I just do here. So how we are going to implement? Okay, so let's just write the code for it. Initially, I will take a main length, right? And let's say it's infinity. See, why I have taken this infinity is because if I compare it any number, it will be lesser than value. Let's say if my number is 0, and if I say is 0 greater than infinity? Yes, it is greater than infinity. So it's just a safe chain, right? So initially my window sum will be 0, and my window starts from where? It starts from 0 as well. Okay, and then what I can do is I will just run a loop that will be my window end. It again start from 0. So my window my window that will contain the subarray elements will always start from 0, and it keep expanding, and it will see it will stop when okay, it will not stop, it will keep adding elements. Okay, and once the subarray which becomes when and once the subarray that has sum greater than equal to the target, what I will do is I will then shrink my window and add the next element to that next element in that. So what it will look like is, and my window end will always be, and see, my window will always start from the zero index. Okay, we will keep expanding the window, keep expand by expanding, I means by adding elements into the window, and we will keep adding elements into the window until my window. Let's see, if I have added elements into my current window. This is my current subarray, right? And its sum is 8, right? And its sum is 8. So the 8, so 8 is greater than or equal to 7, which is target. So what I will do is it satisfy the condition. Once it satisfy the condition, what I will do, I will just calculate the minimum length. Okay, I will calculate the minimum length of this window. So my window start from 0 and 0, 1, 2, 3, 0, 1, 2, 3. So what I will do is 0 and 0 and 3. And what will be the length of this window? And length of the window will be start, sorry, end is 3 and start is 0, end minus start in plus 1 because the index starts from 0, so we have to plus 1 to this. So uh, when we add plus 1, then we will get the window size, and the window size, so get the window size. What is the window size here? The window size is 4 elements here. What is the window size here? Here the window size is 2 elements. Okay, so my window size always start from 0. Okay, window int and window start will always start from 0, and we will keep adding elements into the window, and we will stop when my window int becomes when is, and we will stop once it traverses through the whole input array. Now I will calculate the sum. It will be nums at window int, right? And once my window sum, and once my window sum has become greater than or equal to s, then what we are going to do, we are going to calculate the length of the window, and then we just remove the left part of the window. By left part I mean removing the first element from the window, and then we update update the window size. See, if I start from the 0 and I have added elements whose sum is greater than or equal to 7, then I will start from 1 index, not from 0 index. So that's why I will start the window. So that's why I will increase the window start. What I'm going to do, what I'm going to do here is, if my window sum has become greater than or equal to s, right? I'm going to update my min length. Min length is going to be the math.min length and the current window. So how I calculate my current window? My current window will be window int minus window start plus 1. Plus 1, right? And then what I will do is I will subtract the current window sum from the element that is going out, and the element that is going out is the starting element, right? Which will be nums at window start. And then I'm going to update my window size. So now it will, if previously it start from 0, now it will start from 1. If ever this condition doesn't satisfy, okay, if ever this condition doesn't satisfy, this means what does this mean? If this never satisfied, it means we never found a sub array whose sum is greater than or equal to s. So in that case, what we are going to do here is, if my min length is still infinity that we have already assigned to it, if it's still infinity, what I'm going to do here is I will just return 0. The problem says return 0 if there is no such subarray whose sum is greater than or equal to 7. And in the end, what I'm going to do here is, after this loop ends, I'm going to return the min length. Let's just run it. Okay, so we have got an error. So it's not S, it's target, right? And we have some test cases. I have one test case is passed and the other test cases are failing. Let's see. Okay, so I have made a mistake, and it's uh, the loop. This loop ends here. Okay, so the for loop ends here, right? It doesn't end here. It ends here, and in the end, I will check if my min length is still infinity, which I previously assigned. If it is still infinity, I will return 0. This means I didn't find any subarray whose sum is greater than or equal to the target. And in the end, I will just return the min length. Okay, so it worked. Let's just submit it. Again, this works. Okay, so let's solve another problem, the sliding window. The problem is called fruits into baskets. You can read through the problem, but I will just explain to you what the problem is saying. So basically, we have a farm and we have trees, and the trees have fruits. Okay, and we are given an integer array, which are basically fruits, and these are fruits. And what we are going to do is we have only two baskets, right? We only carry two baskets, and in those two baskets, I can add only two types of fruits. I cannot add more than two types of fruits. See, let's see and understand this with the example. Okay, so again, the how you know how the sliding window works, right? We keep adding elements into our window, and we keep adding means expanding, and then shrinking means removing the first element from the window, right? So when we are going to add one into our window, so it's one type of fruit, right? When we are going to add two into our window, into our current window, it becomes two types of fruits, right? And again, then we are going to add one. It's again two types of fruits. See, one, and two. These are two types of fruits. These are not three types of fruits because one and one is same. So it's the same fruit. So what we are going to do is we are going to return the length, how many fruits we can collect. So in here, we can collect three types of fruits. Let's understand this example. We will add 0, we will add 1, and then when we are going to add 2, what we are going to do is, because it becomes three types of fruit, right? See, 0 is one type of fruit, 1 is one type of fruit, and 2 becomes third type of fruit. So when it becomes third type of fruit, what we are going to do is we are going to remove the first element from the window, and we keep doing it until our window becomes valid again. And how our window will become valid again? It will become valid once we are left with only two types of fruits. And when we are left with two types of fruits, we are again going to add new fruits into the basket. So it again becomes two types of fruits. So 2 and 2 is one type of fruit. So 1, 2, 2 becomes two types of fruits. And how many fruits are these? These are three fruits. So I'm going to return the three. And let's understand this example as well. Let's say I'm going to I'm going to add 1, I'm going to add 2, and when I'm going to add 3, it becomes three types of fruits. So once it becomes three types of fruits, I'm going to remove the first element from the window, and I will keep doing it until my window becomes valid again. So how my window will become valid again? When we are going to left with only two types of fruits. So 2 and 3, so these are two types of fruit. I will again add 2. It's again two types of fruits. I'm going to add 2. It's again two types of fruits. So how many fruits we have collected so far? We have collected so far four fruits. So the output is 4. So the idea is very simple. You got it right. We are going to solve this problem with the sliding window. We maintain a window. See, we maintain a window that expands and shrinks as we move through the array. The array is fruits array, right? Our goal is to make sure that the window contains no more than two types of fruits. We start by expanding the window to the right. By right, I means from left we start. We will keep adding elements into the window, and we will stop once we have three types of fruits. Then we make our window valid again. How do we validate it? We valid we can make our window valid to remove one type of fruit so that we are left with only two types of fruit. So we start by expanding the window to the right, adding fruits one by one as long as we have at most two types of fruits remaining. We keep expanding, but the moment we exceed that limit, by exceeding that limit, when we are going to add the third type of fruit into our window, we stop there because that exceeds the limit. We shrink the window from the left until the condition is satisfied again. To keep track of the fruit types and their counts, we will use a dictionary because we will store the counts of the fruits, type of fruits into our dictionary, into our hash map in JavaScript and other languages and dictionary in Python, right? This allow us to efficiently update the window and know exactly when we need to adjust our window, right? See, the beauty of this approach is its efficiency. Each element is processed at most twice. Once it enters the window and once it leaves from the window. That gives us a time complexity of big O of n, making it much faster and very efficient. Faster than checking all possible subvariants, which will be which if we have to check all possible subvariants, we are going to use the nested loops. The nested loops result in big O of n square. That is a huge time complexity. So the big O of n solution is very much faster and efficient solution for this problem. And the sliding window is great in general to solve such type of problems. What we are going to do here is now again our window will start from 0. Let's say the start is 0 and I will keep a max length initially. The max length is the max length is for the number of fruits we are going to collect, right? And I will have a hash map. Let's say I will call it the fruit frequency, a fruit frag, right? And then I'm going to start my window. So it starts from 0 and stops at once we have traversed through the fruits array. Okay, I will see the right fruit. Okay, so my right fruit is going to be fruits at end. See, we are starting from we are going from left to right. So when we're going to from left to right, so I'm taking the fruit which is 1. Okay, so here it is 1, and I will check if that fruit is already in our hash map. If my right fruit in the right fruit is already in the fruit spec, let's say if it's not in the fruit spec, if it's not in the fruit spec already, what we are going to add, we are going to add this in our fruits spec. We are going to add its frequency. So initially its frequency is going to be 0, and then what I'm going to do here is I'm going to update this frequency to 1. What I'm going to do here is of right fruit plus equals to 1. And if ever my window contains the subarray which has more than two types of fruits, we are going to shrink our windows. By how can we shrink our window? We shrink our window by removing the first element from the window. So I will check how can I check if I have more than two types of fruits? I will check fruits break dot length. If I have keys, let's say if I have keys more than two, if I have three elements in my fruit stack, it means it uh, uh, it violated the condition. It violated the condition. So what I can say, if the length is greater than 2, I can only use two types of fruits, right? What I'm going to do is I will pick the left fruit from the window, and the left fruit is going to be my fruits 8 start, right? And start, and I will just decrease its uh, occurrences. The left fruit is going to be plus minus, right? We are just decrementing the occurrences of the left fruit. And if ever my left fruits, if ever my left fruit count or occurrence become 0, we just delete the left frequency from our hash map. So how can we delete it? We can delete it using delete fruits frac and the left fruit. And what we are going to do is I'm going to update the start window, and after that we will keep calculating the length of the window. The length of the window will give us how many fruits we have collected so far. So it will be method max length and the current window size. The current window size will be the in minus the start and the plus one. And after that we will just return the max length. Okay, so this is our solution for this problem. Let's just submit it. Here we have got an error, so it's in plus plus, right? Okay, so solution is accepted. Let's just submit it. Okay, so it's accepted as well. So we have solved three problems using the sliding window pattern. You can use the sliding window to solve more problems.